My name is Zachary Zach. This is the first episode in a mini-series called Bite-Sized Science. Every episode, I'll explain a science topic. In this episode, I will be discussing one of my most favorite ideas, Supertasks. First, let's take a look at something called Gabriel's cake. It starts off as, well, a cake. One normal cake. A cake that I could eat by myself in less than a day, probably. Now, let's cut this cake in half. I'll have my friend Kid Fisto help me by cutting the cake in half with his lightsaber. Now, since two new sides have become uncovered, the cake's surface area has increased, but the volume has not. Now, let's cut a half in half. Once again, the volume of the cake has remained the same, but the surface area has increased again. Now, let's cut the next half in half again. Continue cutting the next half in half forever. Since the next half will always be able to be cut in half again, the cake has an infinite surface area, but a finite volume. We also need to be able to understand countable and uncountable infinities. A countable infinity is, for example, all the whole numbers in existence. 1, 2, 3, 4, 5, all the way to, well, infinity. Despite the numbers continuing forever, they can be counted, as I just demonstrated. 1, 2, 3, and so on. They are a countable infinity. Now, an uncountable infinity cannot be counted, obviously. An example of an uncountable infinity would be all the real numbers, not just whole numbers, but every single number. You start at 0, but what's the next number? 0.0000000000000000000. And I assume you imagine a 1 fitting into the end somewhere, but where? Where is that 1? Where does it fit? There are as many decimal places as there are numbers. Infinity. So you could never reach the next number after 0, no matter how many decimal places back you went, because you can always add 1 more. And already, there are more numbers in between 0 and 1 than there are whole numbers. It is an uncountable infinity. Now, back to supertasks. A supertask is a countably infinite number of tasks accomplished in a finite amount of time. An example of a supertask would be creating Gabriel's cake in under 2 minutes. You might be saying, "But that's impossible! To create an infinite object, you need an infinite amount of time." Wrong. You can create this infinite cake if, for each step, you take half the time of the previous step. First step, you take 1 minute. Second step, half, 30 seconds. Third step, half of that, 15 seconds, and so on, forever. Since you keep getting twice as fast, you'll never run out of time. Just like the exact same principle that keeps Gabriel's cake infinite, you keep the time it takes you to make the cake finite. Another cool example is Achilles and the tortoise. Achilles, let's say, can run at a speed of 1 meter per second. The tortoise can run at 1/10 of a meter per second. However, the tortoise starts 9/10 of a meter ahead. Will Achilles ever catch up? Actually, no. While most people would say that after 1 second Achilles would catch up, due to common sense, by the time Achilles caught up to the tortoise would have moved to a new spot. It would be 9/100ths away, then 9,000ths, and so on. The distances would get smaller and smaller, but despite what common sense and logic says, Achilles would never quite catch up. The race has become a never-ending supertask. That's all for today, folks, but I hope you stay tuned for more and more mind-blowing science videos. See you soon. Hopefully not in an infinite amount of time.